All right, students, I'm going to go through two examples here of problems similar to problem number 10 in your take-home practice quiz. It's really important that you color code these problems. So we're going to start with this. We're given the fact that QS and TV are of equal length. So I'm going to hatch mark those. You should just watch. So the blacks are equal. And we're also told that RS and TU are congruent. So RS, TU are congruent. We're going to try to prove or explain as a better way that QR, which is the yellows, and UV are congruent. That's what we're going to try to connect. Now, to talk yourself through it, let's start with the basic. The basic is if the yellow plus the red segments both equal the corresponding black segments, the yellow plus the red equals the black, and we're told in the given that the blacks are the same and the reds are the same, we know if you subtract those, watch what we're doing, what's left will be the same, which is what we're trying to prove. So notice where I started. The segments add up to the larger segment. So we're going to come down here. We're going to start with this, the fact that the big segment, US, equals QR plus RS. And the reason we know that little segments add up to big segments, that's called segment addition property. So there's our statement, there's our reason. Click to validate. Now we're going to do the other one, the TV. So TV equals EU plus UV. Little segments add up to big segments. It's called segment addition property. Now keep in mind what we're trying to connect. We're trying to get that QR and UV on the same line. There's QR, there's UV. So somehow we have to say something that's true that gets them connected. And what connects them is right here, US and TV being equal. So that's like the Lego piece that connects the two pieces. So first we have to put that connector down. We're going to send to proof. That's given. So here's what we're doing now. We are saying that if this segment QS, we're going to swap it out and put this in right there. So QS is going to be swapped out with QR and RS. TV is going to be swapped out right there with TU and VU. And the reason why, once again, we're trying to get these two segments on the same line. So I can now say that QR plus RS equal TU plus UV. And the reason is we swapped out from line 3 and we swapped in lines 1 and 2. So we substituted using 3 lines. Lines 1, 2, and 3. We're good. Now, take a look at what we're trying to connect, QR and UV. There's QR, there's UV. At least they're on the same line. Now we have to get them by themselves. if we could get rid of these segments, they would be by themselves. So look in your given. We could swap out one segment and put the other in, and then it'll be the same on both sides. So we're going to go here. We're going to send this line to the proof. Now look what we have here. Here's what we're trying to connect. He just said that RS and TU are exactly the same thing. So I'm going to swap out RS and I'm going to put in TU for line number 6. So exactly the same thing, QR plus, swap in TU equals TU plus UV. That's substitution. And we substituted using lines 4 and 5. Excuse me. Yeah, 4 and 5. 4 and 5. Look very carefully here, guys. See this? QR is the same, UV is the same, and now these two guys are exactly the same. So now we can subtract TU from both sides because it's the exact same thing. And if we subtract TU from both sides, those yellows will be exactly the same. So now we can say QU and UV are equal. And the reason is subtraction property. We subtract the same thing from both sides. That's called subtraction property. And we subtracted from line 6. Ta-da! Now you made your proof complete. Okay, we're going to do another one here, just for practice here. We are given an EF. I'm going to make those squiggle pieces. And we are going to prove that E is equal to DF somehow. All right, so our goal is to make the yellows equal. Well, we know the blacks are already equal, and that this red segment is common to both. So we're going to add little segments and get the bigger segments. So the first one here, add little segments and get the bigger segment. So first I'm going to say our segment CE equals CD plus DE. The reason was segment addition property. Let me recap what we just did there. He said that this big yellow segment is equal to black squiggle segment, which is right there, plus red segment. Yellow equals the black plus the red, which is a true statement. Now we want to do the yellow going the other way, which is DF. So we say DF equals DE plus DF. And that's also segment addition. TF. All right, look very carefully what we're trying to connect. We're trying to connect these two guys, DE and DF. We're trying to connect them. Now, look very carefully. we know that CD can be swapped out for EF. So for this line right here, at first I'm going to say they're equal, and then I'm going to swap out CD for EF. So I have to say my given. Now look what we can do now. The CD, EF, I'm going to swap one for the other. It doesn't matter which one. Okay, so I'm going to do the first one. You can manipulate one or two. It doesn't matter. I'm going to focus on one, and I'm going to swap out the CD, and I'm going to put in EF. And you'll see why in just a moment. So CE equals EF plus BE. That's substitution, and we use lines 1 and 3. Now look very carefully. Remember, we're trying to connect DE and DF. That's what we're trying to connect. Now look at what just happened. Do you see DE and EF? See DE and EF? These are the same thing. So if the red's the same, we can now say that the yellows are the same. And that is substitution property as well. So I can now say CE and DF are the same. And the reason why, because we substituted DE and EF, DE and EF, we swapped this into there, or you can say we swapped that into there. It doesn't matter, but we use lines 2 and 4. Substitution property. So there's 2 examples for you to work with for problem number 4.